Okay, in 17.3, we're going to look at some more specific numbers on the normal curve. So this is called the 68, 95, 99.7 rule. You'll probably use this one piece of information for more homework problems than anything else in this entire section. And mainly what it's saying is that 68% of the data falls between one standard deviation of the mean. So the mean's in the middle here, and whatever the standard deviation is, could be 10, could be a million. If you go one above the mean and one standard deviation below the mean, then 68% of the data falls between here and here. All right, picture some other stuff that probably tells us, and we'll go through and try to fill in all these little spaces in a second, but something else that tells us, since we know that this is perfectly symmetrical, if 68% of the data is between here and here, that means there's 34% on each side. So we'll think about that stuff later. Okay, so then within two standard deviations of the mean, so it could be in either direction. So if I go up to +2 standard deviations, so let's say the standard deviation was like 10, this would be +10, this would be +20. And 2 standard deviations below the mean, so in this shaded area, 95% of the data falls. And then if I go 3 standard deviations away, so +3 in either direction. So +3 this way, and then -3, so below. 99.7% of the data falls within there, so almost all of it. Okay, so if there's one thing that you want to have labeled, if you can label all these individual little pieces, you can use them all the time. And so I would fill one of these out. I think there's a homework question even where they have you fill some of it out, but if you don't already, I would draw this diagram in my notes and use it on all the homework questions so you don't have to reinvent the wheel every single time. Okay, so the first one, let's say, and then another thing to keep in mind before we get going on this, all of the data represents 100%, right? We can't go more than 100% of our sample size. So first one, if 68% is between here and here and it's perfectly symmetrical, wouldn't that mean that 34% is on this side and 34% is on this side? So just between here and here. Okay, so then how can I get this one filled in? Well, picture if 95% of the data falls in this whole region, right, including this middle part, so how much is left? Well, if the whole thing between here and here is 95%, and we already have this middle 68% accounted for, how much do we have left for this piece and this piece? So 95 minus 68, so 7, we borrowed here, so 27%. Okay, so if I have 27% left, and I know it's perfectly symmetrical, that 27% have to get split up evenly between here and here. And so 27% divided by 2 is what? 13.5? So I know out of that 27%, 13.5% goes here, and another 13.5% goes here. So you can get a lot from just the 68, 95, 99.7 rule, knowing that this thing is perfectly symmetrical. So you're just kind of every time saying, well, what's left? Well, what's left? Well, what's left? Okay, so then for the last little pieces, I know that 99.7% of the data falls between here and here, but that's already including these numbers we've already used, right? And so if 99.7% of the data falls between 3 standard deviations, and we've already used up 95% of the data, right? We already have this middle 95% taken care of. So how much is left? Well, it looks like 4.7% for this piece and this piece together. So how much do they each get? Well, half of that, so 4.7% divided by 2 is 2.35%. Okay, then don't forget there is a little bit of data here. Some people can do better. You know, very few people, maybe it was a test or something, did better than 3 standard deviations above the mean. That's a very high score, but it doesn't mean there's nobody out there. So how many people are out there? Well, if all the data represents 100% of the test scores, but 99.7% of that falls within 2 standard deviations, or sorry, 3 standard deviations of the mean, the only stuff we don't have accounted for is the other 0.3%, so almost nobody, right? Let me pick a new color. Okay, so almost nobody's way out here in these outlier parts. But total, this little piece and this little piece add to 0.3%. So individually, they most each be half of that because we know this thing is perfectly symmetrical. So 0.15% of people do better than or worse than 3 standard deviations above or below the mean. So I would keep this exact diagram with these numbers. I think there'll be test questions, honestly, to recreate this because it's so important. So if we know 68, 95, 99.7, you can figure out all these other numbers from that. It's the middle 68 and then how much is left out of the middle 95, how much is left out of the middle 99.7, and how much is left out of 100% after that. So if they ask you any questions, like they're going to in this next little part, you can use this diagram to answer them a lot more easily. Like let's say if I said how many people did, I don't know, worse than, let's see, how many people did worse than this? I wouldn't have to come up with all the stuff. I could just add these numbers all together and I know exactly how much data is lower than that. Or I could figure out how much data is above that, which is what, 2.5% if I add these two together. And so this must be the other 97.5%. And so having these on here means you don't have to reinvent the wheel every single time. You've already labeled all the regions that are 1, 2, and 3 standard deviations below the mean. The other one we don't have on here, and you usually don't throw on the same diagram just because they get so cluttery. But remember from the last section that if we wanted this, the first quartile and the third quartile, so if we wanted 25% of the data, we'd go not one whole standard deviation away. And you can kind of see that here. See how this adds to 2.5. And if you added this, that would give you 2.5 to 13.5 would give you 16. So if you cut right here, this is 16% is lower than that. If you want 25% lower than that, you got to come in a little closer. And that's where that 0.675 standard deviations below the mean comes in. So Q1 and Q3 would be kind of roughly here and here, because you notice if you go a whole nother one, this is half the data. So if you want 25%, it's kind of right in this region as the cutoff. Okay, so whenever they ask a question using any of this stuff, I would draw it. I think in this one they don't, but it's way easier to see. I'm going to draw it on here. It's way easier to see what you're doing if you're looking at it. Okay, so here's one where SAT scores. The mean was 515 and the standard deviation was 114. Okay, so the mean is in the middle. And so the median must be close to that. Q1 and Q3 are 0.675 standard deviations away. So it looks like 0.675 of a standard deviation, which is 114. So if I go below the mean, I end up at 438. And if I go above the mean, that same amount, I end up at 592. Okay, then the 68, 99, 95 thing. So I'm going to try to label on one of these. So they'll say 68% of the data was between here and here. So if they go one standard deviation below the mean, so 515 minus 114 is 401, 515 plus 114 is 629. So all of this stuff that they're saying right here, I'm going to skim through it really fast because we're going to draw a picture. Oops. And let's just draw it on top of this one. Everything they're trying to say about the SAT scores, you can sum up way better on the picture. Okay, so we know that the mean was 515 and the standard deviation was 114. So that means half the people did better than this, half the people did worse. So if I want to go 1 standard deviation above the mean, it's 515 plus 114. So 114 represents 1 step or 1 standard deviation. So that's what, 629? If I want to go below it, 515 minus 114 is 401. So now let's do 2 standard deviations away. So let's say 515 plus 114 plus 114 again. And 3 standard deviations would be plus 114 again. So these are the actual test scores that correlate to the z-scores of 3, 2, and 1. The z-score being how many standard deviations above the mean are you. And so then 401, if we want to go another 114 below that, is 287. And another 114 below that is 173. And then remember we had all our percentages figured out from earlier, so this is 13.5%, so is this. This is, oh sorry, put it in the wrong spot. This is 13.5%. This is 34%. This is 2.35%. And this is 0.15%. I'm just going to label on one side because both sides are the same. Okay, so let's say someone asked us literally almost any question now about SAT scores. It'd be way easier to answer off this diagram than it would be just doing the work kind of numerically in a little paragraph. So let's say they'd said, I don't know, you got a 401. What percent of people did you do better than? What percent of people did you do worse than? Well, you did better than the 0.15, the 2.35, and the 13.5% of people. In fact, we'll put them in here. 2.35 and 13.5%. So you did better than 16% of people, if I add all those numbers together, which also means you did worse than the other 84% of people. And so using these numbers and just being able to see them on the diagram is definitely easier. Or if somebody said, you got a score of 743, what's the z-score that corresponds with that? You can look right here. Not every single one will fall perfectly on a standard deviation, so then you have to use the formula. But this one did, so you could say, oh, that means I'm 2 standard deviations above the mean. The person who got a 401, you can see, is 1 standard deviation below the mean. So a 401 is the same as a z-score of -1, which also means that it's like the 16th percentile. You did better than 16% of people. So that's how this gets used as a measuring stick. It's whatever your data is, you can put the middle and then go 1, 2, 3, -1, -2, -3 standard deviations around the mean, and then you can tell pretty much anything they're going to ask about it from this. I would not suggest trying to answer these without drawing them. It's way easier to see when you draw it out, plus you could have this already pre-labeled percentage thing, because the percentages aren't ever going to change. You could have the pre-labeled percentage thing in your notes and then use that on the homework questions. So I could tell you anything you wanted to know pretty quickly off this diagram now about SAT scores.